for the invitation, because I think that in this moment we are not landing at the end of the trip with additive manufacturing, but we are exactly in the middle of the ocean. And we have to sail a little bit together, because since it's an ocean, there are too many topics that we have to study, that we have to develop. Of course, redesign is one of the topics that we have to develop, but our vision in additive manufacturing is that, as told this first speaker, is a very, very, very interdisciplinary topic. And if you would like to be a key player in this frame, you have to build up complex systems where designers work together with material scientists, with people able to work in ICT, and with a mechanical engineer able to modify the machine. We are exactly at the beginning of the trip. We have to understand where the market is going. We have to try to modify the machine for additive manufacturing, because one of the steps will be additive manufacturing, design on the products. And to do these steps, you need understand of the redesign, you need to understand of material science, because when you redesign a component, if you don't understand nothing about material science, you can't exploit every possibility. Usually you have to design a part, understand the mechanical thermal stress that you have inside of the part, understand if modifying the material, you can modify again the design, and so on. So at present, we need new suites to compare the design with different material, to understand what happened really inside of the design of component. And to do these steps, you need too many different know-how and too many different competence. So, which has been our starting point? We're starting from a joint venture between my department, so material scientist, and technologist. Professor Luca Giuliano is a colleague of mine, and we started together 10 years ago, walking in the street of additive manufacturing. And of course, we have been lucky, because we stay in a region where some different big companies try to understand what additive manufacturing could do for industries. One of the first examples has been Avioaro, that started in 2007 to work on this topic. And since we have been there, we've been the partner in these studies. Now, this is our team. We are more or less 25 to 30 people. We are at 10 faculties, and more or less 10 to 15 PhD students, postdoc researcher, active in this field, and active only in this field. We are not only Politecnico di Torino, because in 2010 IIT, Italian Institute of Technology, came in Torino to make labs together with us. And they have also people in staff active in this field. And this is the bridge also between the two departments and on this technology. This is our timeline, historic timeline. As you can see, we had our first machine in additive manufacturing in 2005. That was not exactly a machine for additive manufacturing, because EOS M250 was able to work only on a little number of materials, because it was not able to work on reactive material. So that machine was mainly a machine for rapid prototyping, metal rapid prototyping. And the real difference, in my opinion, between additive manufacturing metal additive manufacturing and rapid prototyping is the capability to work on different material and to obtain component with mechanical properties comparable or better with respect to what we can obtain with traditional technology. And that machine was not able to do this work. In 2007, we started with Avio Aero the long walk for what the story that at present I think is the most successful story in additive manufacturing, that is the story of the blade in titanium aluminide, a particular material with a particular component, with a particular shape, with a very big market, with a high cost of component, so the perfect story for additive manufacturing. But in that moment, we need, of course, a success story. And this is the first story that we follow. From 2007 to 2010, we worked very hard with EBM technology, Arkham EBM technology, so Swedish technology. And we support Avio Aero in the definition of the process parameters, in the definition of all the post-processing to optimize the mechanical properties. And in 2010, we've been at the first, that was not a conference, was a workshop, the final workshop of Impress project. Impress project has been a project focused on titanium aluminide alloys, the application of titanium aluminide alloys in the aerospace market. And in that workshop, we show our results. Well, at that time, that result has been a little bit strange. Nobody believed in our results. But the story said that in 2012, General Electric bought Avio. And the story of the blade in titanium aluminide has been one of the reasons because of this step of General Electric. So from 2010 to now, the world completely changed. And the world completely changed the approach in additive manufacturing. As everybody can see, the European Commission, the United States put too much money on this kind of technology. And we have been lucky also in this frame, because in 2010, IIT, when started these labs, give us the money to bought the first EOS machine, M270 machine, that is not too much different with the machine that EOS sell now, because from between M270 and M290, there is no difference in the capability of process materials. So we are more or less able to develop material, develop component in additive manufacturing since 2010. We started to work at the beginning, because that was one of our choice, on aluminum alloy. For several years, we've been the first institution able to work on aluminum alloys. We tried to modify the composition. We tried, starting from the standard aluminum alloys that EOS has in his book. We worked on 700 series, on 7,000 series, 2,000 series. We tried to mix aluminum alloy with ceramics to make composite. We tried to direct alloy inside the machine, the aluminum alloy. And we did this work together, jointly, with the technologists that in parallel developed the redesign of component, developed the capability to put the component inside the machine in the right way in order to minimize the residual stresses, optimize the capability to grow the component, and so on. In parallel, too many European projects started in Europe, and we've been part of a major project that was focused mainly on the development on new material for additive manufacturing, but other projects, e-brake and titanium aluminide chargers, are more focused on components, so in the aerospace frame or in the automotive frame. And this is another reason because of the interdisciplinarity, very important. You need interdisciplinary. In 2015, we had a new step change because an Italian company active in the field of laser machining, Prima Industrie, come in our institution and ask us if there were, in our opinion, some way that they could take to be part of the market of additive manufacturing. So in 2015, we started to work also with, let's say, with the companies active in the field of machine production. And we get the Borealis project, where they develop, together with us, a direct deposition machine that works exactly in the direction that told you the previous speaker, with some other advantages. Speaking about direct deposition, we mean have in mind a machine able to modify the material along the component that you are producing. And this is not possible with standard powder bed technology. It means that you can have the idea to start a component with, I don't know, titanium 64, and complete your component in aluminum alloy, without joint inside the component, just modifying the alloy along the component. You know that brazing and joining component mean put inside the component some weak part. If you are able to modify step by step the composition, you don't have this problem. And this is, again, another way to understand the design for additive manufacturing. Of course, you need another machine. Another rule in additive manufacturing is that usually the technologies are not competitor between them, because you can do something with laser powder bed machines. You can do other thing with EBM powder bed machine, and you can do other things with direct deposition. Another reason, because you need critical mass when you build up systems, because you need too much money to have in-house all the machine to make all the steps that you need. Okay, this is 2015. What we are doing now. We just started a new partnership with the Avio Aero and General Electric. They come in Politecnico di Torino again, and we build up together a joint lab, a PPP lab, where they put at present 4 machines, 2 EOS M400, 1 EOS M290, and 1 concept laser M2. What they want to do inside these labs, they want, by one side, make some, let's say, technology maturation on components, since they are the focal point for the new General Electric small engine in Europe. And they have to produce 13 parts for this engine direct with additive manufacturing. ATP will be the aircraft engine with more parts produced in additive manufacturing in the next future. On the other hand, they need our competence in material science, because they would like to develop new alloys, new parameters for new alloys inside the machine, especially with respect with concept, because they both concepts, so they want to understand exactly how does it work. Our interest is work both on concept and on EOS, because we are working with all the company. My experience is in material science, so my interest is develop new alloys. But on the other side, they would like also to understand if they can modify the machine. So we have to add new competence in our group because we need the people active in the field of laser sources. This is also true about direct deposition that we spoke before. We choose other people in the field of computer science because we had to have smartness inside the machine. One of the problems of additive manufacturing at present is, if you speak about machine, that if you think about powder bed, you start your job and up to the end of the production, you are not able to ensure the quality of what you did. You don't have any way to make an inline analysis of what happened. So this is another step that we are investigating with the other let's say, peoples with different competences. So this is what we do with Aero. In this year, also our institution invests in this direction. They give us 3 million, and we integrate our lab with an IBM Arkham A2 machine that is now not working because we are completely in the building, but we have in-house the machine. We are just to start to follow up the work that we did with General Electric in developed materials. A small machine that we are buying with IIT to be able to modify the composition of the alloys directly in our machine and set up the parameters of the machine. And not exostatic press, not only for heat treatment, final heat treatment, but also to develop net shape peeping technology. And finally, at the end of the next year, inside these 3 million, we will buy also a gas atomization system. Why? Because we want to be able to manage all the supply chain of the development in additive manufacturing in-house. It's quite easy now if you go from some powder producer, ask them for a particular alloy, but it is not easy to make studies around this composition. So if you ask for aluminum alloy with 6% of silicon, what happens if it is 6.5? What happens if it is 5.5? Is different, is the same, especially when you add some precious metal or some, I don't know, materials that you need in small quantity. You have to manage exactly the level and what happens inside the machine when you work on that. So we would like to be independent in this study and able to do these steps. Because, again, you need material and technology working together. So we have other European and national projects. We won last year a feasibility study for an European hub of digital manufacturing that we focus on this technology. In 2016, we win some prizes from JTI and from EPM and from European Powder Metallurgy Association for this component made in net shape peeping technology together with Ober and Duval and Avio Aero. So we have some visibility in this. Okay. This is roughly what we did in the last period. This is just to show you that at the beginning, the investment, public investment and private investment was not too much in this direction, but especially from the private side, there is a big growth in these last years, and this is an indication of the interest of the company in this direction, because of course it is usual that before the research and after the companies, but we are exactly in the moment where you can find the interest of the companies and especially to understand what they can do and what they can, which are the steps that they need, they are able to put some money and share with the university what they are doing. I think that the joint venture between companies and university in this frame is fundamental. It's fundamental because additive manufacturing is a technology that ensure the capability to make research from TRL 0 to TRL 9. So you can cover all the strip of the TRL, the technology level of the innovation, and support the company up to the final component. So also the idea of competence center that we already have in Piemonte is very, very similar what you want to share in the next speech, and we trust too much in this direction because you need the public-private investment. This is just to share with you the signature of the last partnership, and our lab, our joint lab with General Electric has been in the center of the SIDES event that we had 2 weeks ago for the Carnegie meetings, for the G7 meeting in Torino for industries and research. We had all the ministry, and we showed them how does work our joint lab. There were a nice speech about Giorgia Bratt, that is the head of the engineering of General Electric. And this is the frame where we work together with them. He stressed too much the different level of the technology that they share with the university, that they understand, starting from the particular material for particular application, up to what said the speaker before, the possibility of produce complex component. This is just a picture of all the competence that we are adding at our center. Last but not least, very important, the education. Politecnico di Torino started last year the first master course in additive manufacturing, built up on our mechanical engineer course. I'm teaching right now material for additive manufacturing in a course where there is a course of material for additive manufacturing, a course of technology, and a course of redesign. If someone needs, there is the link. And we had also some specializing master after the master degrees, especially in additive manufacturing, but these courses are with company, directly with company. This is the frame of our competence center. I will run just because I'm a little bit late. Apologize. And these are the competence on which we are based our competence center: IoT, advanced additive manufacturing, and energy management. So I have to close. Thank you very much.
So thank you so much, Paolo.